All right. I wanted to spend some time reviewing camera trapping this week as I just bought a handful of game cameras to set up to monitor a coyote den near one of our nuclear waste facilities. I've done some camera trapping in the past, and you'll see some of the photos from that on the background slides and a few slides I've got to come. And we set up those cameras on a habitat restoration site in southern Arizona. We set those cameras up to observe which species were utilizing the habitat and the plants that we are reintroducing on the site. So here is an elk just mowing down a cottonwood pole that we had installed. Cameras are an efficient way to monitor or provide continuous sampling and monitoring in difficult to access areas while limiting disturbance to wildlife populations. Let me go back. I'm only familiar with camera trapping being utilized for terrestrial species, though recently I heard about a fish doorbell, I think in the Netherlands, and there's a website for that. Go check it out. It's really kind of funny. So I'm sure there are aquatic applications for camera trapping as well. Let's see. Camera trapping can be useful for a lot of different things and be used for a lot of different scientific studies. Cameras are generally becoming more reliable, increasingly portable, cheaper, and more user-friendly than models available in even the recent past. So their application is growing as well. And one of the main attractions, I think, is that remote cameras can provide can minimize our risks to wildlife and minimize our disturbance to wildlife populations while improving our data collection. That being said, the effectiveness of camera trapping is dependent on a few things, battery life being one, data storage capacity, and picture resolution. Those are the main ones, though I've got a few more that I'm going to outline for you in just a second. Things that we want to keep in mind as you're shopping, I guess, is trigger speed, detection zone, field of view, recovery time, and the camera's ability to take nighttime pictures, which can be very useful as well. With these aspects, camera traps are becoming increasingly used to study plant-animal interactions like seed dispersal and predation, like that elk killing my cottonwood pole. There are a number of reasons why camera trapping may not be the best tool or method for data collection on your projects. Unfortunately, even though it might limit the impact to your target species, those sound impacts are not negligible. Just the trigger itself can disturb a species, so it may impact your behavioral study of the target species. Even worse, it's not uncommon that cameras are stolen or those cameras fail in the field. The next two items on the list here are mostly related to trigger times, might be inadequate for particularly small species. So that's partly why there's limited application for those smaller species. It's also limited repeatability. Science really likes you to be able to set up a project and for other studies to repeat your methods. Camera traps are very unique and time and location specific. And in that way, and partly from the considerations like the field of view, your observations can be incomplete. So just a few things to think about. However, that all being said, it is an expanding field. It's a very attractive tool that garners a lot of public attention. I've got a picture here of one of the jaguars that's been captured on game cameras in southern Arizona. It is a way to get a lot of positive attention for your projects. Photos go a really long way in science, as crazy as that may seem. But it could help you get funding to show how your sites are being used. So because of that attraction, a lot of scientists are finding innovative ways to use camera traps. So there's this huge potential to use camera traps to generate new and important data and spur, creative problem solvers to come up with new analytical innovations and again, to capture that public attention. So with that, I will end here, and I appreciate your attention. Thanks.